Question 10. Okay, so this is our penultimate question. The figure below shows that a Bunsen burner heating some water in a beaker. Eventually, the water changes into steam. Explain how the internal, so the internal is to do with your energy kinetic plus your energy potential. Explain how the internal energy of the water changes as it heated from 20 to 25. So if it's 20 to 25, it's increasing temperature, so it's fully about kinetics. So you would say that the internal energy, and it's to explain, so we've got to say why, will increase as the water particles gain kinetic energy and move faster. Explained, internal energy will increase, 1 mark. Explain how the internal, right, as the particles in kinetic energy move faster. Yep, that's absolutely fine. Okay, how is a particle model used to explain the difference in density between a liquid and a gas density? That is the distance between particles. So the particles in a gas have less kinetic energy than the particles in a liquid. Well, kinetic energy is to do with speed, so it's not going to be that one. The particles. The particles in a gas have more potential energy, so that is to do with distance. It's how spread out they are than the particles in liquid, so it might be true. The particles in a liquid are further apart than the particles in gas. Again, that's to do with spread out, so that might be true. The particles in a liquid are larger than the particles in the gas. Well, that's not true, because in the particle model, all the particles must be the same size. So it's going to be either one of these. Let's read them more carefully. The particles in a gas have more potential energy than the particles in a liquid. Yes, that's true, because they're more spread out. So that one's true. The particles in a liquid are further apart than the particles in a gas. No, that's not true, because the particles in a gas have more spread out. So it must be this one. And does that? Yes, that explains the question. Right. C. A student measured the mass of boiling water that was turned into steam in 5 minutes. 5 minutes is the time, and we want that in seconds. 5 times 60, we should give you 300 seconds. So, a student measured the mass of the boiling water that was turned into steam in 300 seconds. Explain, so say what happened and then say why. How the student could use this information to estimate the power output of the Bunsen burner in watts. Okay, tricky question, this one. It's one where we're going to have to show a formula, but we aren't being really given any numbers apart from we've been given a time there. So we're going to have to use a formula that's going to have power in it. They're heating it up, and this time it's going to have power and time. Let's have a look at our formula data sheet. And let's take that off. So let's have a look for the power ones. Power, energy transfer divided by time, work done divided by time. Probably could use either of these. Energy transferred divided by time, or work done. Well, work done and energy transferred are pretty much the same thing. So let's go with that formula for now. Power equals energy transferred divided by time. So power. So if we want to find the power, we could do energy transferred divided by the time. And we know the time because power is going to be energy transferred divided by 300. So that's okay. How are we going to get this energy? So this is going to be a link equation. Well, what have we got? We have got, do we know the mass? We don't know the mass. We know the time. That's about it. So we need to find the energy. So energy equals, and we've got a time. Or we can do something with time. We've got time, and we've got some water, and it's changing, turned into steam. So that's to do with latent heat. Let's do latent heat. So we've got the idea: energy, latent heat, and time. Okay. Oh, and we know it's water. So water will have a specific latent heat. So let's just check the formula sheet again. There we go. So this one here. Energy is equal to the mass times by specific latent heat. Okay. Mass. Do we know the mass of the water? Let's have a look. Not on here. Do we on here? Well, we could find it, couldn't we? So they could find the mass of the water because they could just do a bit of experiments. It's just to get the mass. We should write that down. So get the mass of the water using an balance, and then you could use energy equals the mass of the water times by the specific latent heat of water. Yeah, that would work, and that will give us our energy. So our formula becomes, it's quite big, power equals the mass of the water multiplied by the specific latent heat of the water divided by the time of heating, which in this case was 300 seconds. Okay, that's how they would do it.